All right, welcome back. Today we're going to look at a specific type of sequence called an arithmetic sequence. We're going to look at how to define, identify, and apply arithmetic sequences. So an arithmetic sequence is a sequence of numbers where the difference between consecutive terms is constant. We call this the common difference. So to look at an arithmetic sequence, we start with the first term. To get to the next term, we add this common difference. So we add one of our common differences. To get to the third term, we're adding it a second time. So we have two of these common differences. To get to the fourth term, we're adding three common differences to our first term. So we are always adding a common difference to the previous term. So to make for something to be an arithmetic sequence, we are always adding or subtracting, if our number is negative, a constant. Okay? So if I were going to define this recursively, remember we have to start with an initial condition. So we state whatever that first term is, and then we describe what are we doing to the previous term. So my previous term here, a sub n minus 1, we are simply just adding our common difference to that. For an explicit formula, we take our first term and we add our common difference, but it's always being added one less than the position it's in. And what I mean by that is, to get my first term, I didn't have to add d at all. To get my second term, I had to add 1d. To get my third term, I had to add 2d's. To get my fourth term, I needed 3d's. So it's always going to be one less than the position you're in. So n stands for the position. We take one off of it. That's how many of our common differences we need to add in. So to write a recursive or an explicit formula, the first thing to do is identify your first term and what that common difference is. And then we're simply going to plug them into the proper format. Remember that recursive will always have that previous term in its formula, and an explicit formula is always going to be using an n. We're going to relate it to its position. Explicit ones should always be simplified. All right, so find the explicit and recursive formulas for the following arithmetic sequences. So looking at our numbers here, we're going from 2, 5, 8, 11, 14. It looks like I'm just adding a constant. To go from 2 to 5, I'm adding 3. To go from 5 to 8, I'm adding 3. To go from 8 to 11, I'm adding 3. To go from 11 to 14, I'm adding 3. If they tell you it's an arithmetic sequence, then we know that we're simply adding or subtracting a constant. So to find your d value, you can simply take the second term minus the first term. What is it that we did to it? So 5 minus 2, in this case, gets us a 3. That's my common difference. So I know my first term and I know my common difference. That's all I really need to write my recursive rule. So I can start out saying that my first term is a 2, and to get every term after that, I'm going to take the previous term, a sub n minus 1, and simply add 3 to it. Okay? Now, they also asked me to write an explicit rule for this, or an explicit formula. So to do that, we're going to go back to our formula. It says, to find any term in my sequence, I take the first term and I add to it my common difference, but I do that n minus 1 times. All right. So a sub n equals the first term plus n minus 1 of those common differences. Okay? Well, I know my first term is a 2, and I know my common difference is a 3. So now I just have to simplify this expression. So we do have to distribute the 3. So we have 2 plus 3n minus 3. And then I just want to simplify, combine my like terms. So a sub n equals 3n 2 minus 3 would be negative 1. So 3n minus 1. So I've got my recursive rule, and I have my explicit rule. Okay. Second example. We have 6, 1, negative 4, negative 9, negative 14. Again, they're telling me it's an arithmetic sequence. So to find my d value, I simply take my second term and subtract my first term. So in this case, it looks like we're subtracting 5 each time, or adding a negative 5. So my recursive rule says my first term is a 6, and all the terms after that are going to be the previous number minus a 5, or plus a negative 5, either way. Okay? My explicit rule says a sub n equals my first term plus that common difference added in n minus 1 times. So my first term is a 6. My common difference is a negative 5. So we have to be careful here when we're multiplying or distributing that. So we get 6 plus negative 5n, and negative 5 times negative 1 would be positive 5. So my simplified answer here would be negative 5n plus 11. All right, to find the nth term of an arithmetic sequence, we want to use the explicit formula. Unless we're being asked for like the second or third term, we really don't want to use a recursive rule because we have to generate all the terms that lead up to the one I'm looking for. With an explicit formula, we can just use, plug in our n value, and we'll have our answer right away. So for these next two, it says to find a recursive formula and an explicit formula, but then there's one extra piece here. They're asking us to find the 15th term. So to do that, we are going to use our explicit rule. We are told here they are arithmetic, so we know that there has to be a common difference. So again, to find our d value, we take our second term and subtract our first term. So this time I'm adding 4, and if you check it, 6 plus 4 is 10, 10 plus 4 is 14, 14 plus 4 is 18. It seems to be working. Okay, so my recursive rule will say the first term is a 6, and all the terms after that are going to take the previous term, so a sub n minus 1, and simply add 4 to it. Okay, my explicit rule says the nth term will take the first term, which is a 6, plus n minus 1 of my common differences, which in this case is a 4. So distributing, we've got 4n minus 4 plus the original 6. So my formula would be 4n plus 2. Then to find the 15th term, we're going to actually use that explicit rule. So a sub 15, we simply plug a 15 in for n. So 4 times 15 plus 2, and we would get 62 for the 15th term. All right, let's try another one. To find our common difference again, we're going to take second term minus the first term. So we end up with a common difference of 1.5. So we're just adding 1.5 each time. So my recursive rule, my first term is a 3. All my other terms will take the previous number and add to it 1.5. My explicit rule says the nth term will take my first term, which is a 3, and add n minus 1 of these common differences, 1.5. So distributing, we've got 3 plus 1.5n minus 1.5. And then combining like terms, we have 1.5n plus 3 minus 1.5 is 1.5. All right, now find the 15th term. 1.5 times 15 plus another 1.5, and we end up with 24. All right, our last one, it says the number of seats in the first 13 rows of a section of an arena form an arithmetic sequence. Rows 1 and 2 are shown in the diagram. How many seats are in row 13? Since we want to find the 13th one, we want an explicit rule. Or explicit formula. We don't want to have to find all rows. We just want the 13th one. So we are told that our first term, according to this picture here, has 14 seats, and our second term, our second row, has 16 seats. And they did say it forms an arithmetic sequence, so that means we have a common difference. In this case, we're simply adding 2. All right, so my formula says a sub n equals first term plus n minus 1 of these common differences. I can distribute. We get 2n minus 2 plus the 14, so my rule says 14 minus 2 would be 12, so we have 2n plus 12. That's the formula that's being used to create the sequence. Now, they want us to figure out how many are in row 13. So we want to find a sub 13. We simply plug a 13 in for n. So 2 times 13 would be 26, plus 12 more, we'd have 38 seats in that row. All right, so you guys are going to be working on a worksheet 9.2a.